So today we will discuss about the question course schedule. So in course schedule, we are given a list of courses and we need to tell if we can complete those courses or not. There is also a prerequisites array given to us which tell us that a particular course is dependent upon another course, which basically means let's say there are two courses, 1 and 2. So 1 is dependent upon 2. So you have to complete course 2 before completing course 1. So let's understand it with an example. So let's say there is a course A and it is dependent upon course B. Similarly, there is a course C that has to be completed before completing course B. And now let's say A is also dependent upon course C to be completed. And let's say C is dependent upon course D. So you see, you have to tell whether you can complete all the courses or not. So here you can complete course D, then you can complete course C, then you can complete course B, and then you can complete course A. Now let's understand what we have done. So there is a dependency between two courses and we have expressed dependency in a form of graph. So what does H denotes? H from A to B. So it tells that you have to complete course B before A. Now how we can solve it? See, what we can do is, so the basic idea comes in our mind is, let's say there is a dependency of one course from two other courses. So one simple approach comes in our mind is recursion, right? Where with recursion you complete dependent course first. Now second approach comes to our mind is, so let's look at it backwards. So which course we can complete first? One which has no dependency. So we can complete it from bottom to top. So essentially they both are same thing. It's just that the approach to look at it is different. So in recursion we start from A and then we recursively try to complete the course which is it is depending upon. And then when they are completed we complete course A. But in bottom to up approach we choose the course which has no dependency. Let's say we complete course D first. Okay. So now let's look at bottom to up first approach first. We will use the concept of in degree and out degree. So let's mention the in degree and out degree of each nodes here. So if you see nodes in degree and out degree. So for node A, B, C and D. So A has in degree of 0, out degree is 2. B has in degree of 1, out degree as 1. C has in degree 2, out degree 1. D has in degree 1 and out degree 0. So we will select the node with the out degree 0 here D, because out degree 0 basically means that it has no dependency, right? So now what we will do is we will select the node with out degree 0 first. So we will, let's say we selected the node D. Now which data structure do we need to iterate backwards? So what do we need? Do we need to keep D? No, right? We need to take it out and then attend the first inserted element. So it is kind of FIFO. So we can use Q here. So we will use Q. We will insert D. Now what we can do is, now we need to see, okay, now if D is completed, what all courses we can complete. So when D is completed, all its dependencies will also be removed. So we will remove its dependencies. Let's remove these dependencies. Now what we are left with, let's create a in degree out degree again. So let's say we have nodes in degree out degree. A has in degree of 0, out degree 2. B has in degree of 1, out degree is also 1. C has in degree of 2 and out degree of 0. And D is already eliminated. So let's remove it. Now you will see we have C as a candidate. If we see, we do not require in degree. So next time we can skip like in degree altogether. So now what we will do is we will remove D from the queue and insert C, right? So now what we will do is, since C is completed, we will remove it and all its dependencies. So now we see C is completed. So what we will do is we will remove C and all its dependencies. So let's remove C and all its dependencies. Now what we are left with is two courses A and B. And to complete A, we need to complete course B first. So what we will do is we will remove C here. So we will keep the count of nodes and out degree this time. So what we will observe is that A and B. For A, out degree is 1, for B is 0. So we will select B. So we will insert B in the queue. Since B is completed, we will remove B and all its dependencies. So now we will remove B and all its dependencies. So now we are left with A. So now we will check the nodes and in degree. So here node is A and its in degree 0. So now we will select node A first and then remove it. So this is how we are going to complete, and we will know the way we can complete all the courses. So where we cannot complete all the courses. So let's take one more example here. Now let's take a simple example. Let's say A, it is dependent on course B is dependent upon course C, and C is depending upon A. So here if we will like like we can quickly iterate over it. So, and let's say we have another course. So we will see, we will, if we keep the count of nodes and in degree and out degree, we will see that node D out degree 0 will be selected. But if we will remove the all the dependencies of D, let's say we remove it. Now we are left with no node with out degree 0, but still we are left with C nodes. It means there is a cycle. So what we can say is that if we have no candidate with out degree 0 and still all courses are not completed, we cannot complete. So this is going to be our condition. So here if we see, if we remove C, will be left with out degree of 1. So C will have out degree 1, we cannot complete it. So what we will do is we will return false. So one more correction in the previous thing, here it should be out degree. So now let's jump on to the coding part. So now what we will do is we will first create a dependency graph for it. So we can name it as dependency for now, dependency, and its dimension is going to be number of courses, and number of courses are 0 index, so it's fine. So now we will take all the dependencies of, let's say, prerequisite that we are given, requisites that we are given. Now we will see, what we will do is, so here we will insert it in reverse order, because we need reverse way of knowing that from which node the current node was currently depending upon. So from my current node, how many nodes are depending upon my current node, we need that information. So for that we will create a reverse graph. We will also maintain an out degree array, or we can say in degree of the reverse graph, that is also fine. So now what we will do is we will create a queue. We will go over all the courses. We will insert it into the queue, and now we will check while it is not empty. My current is going to be the queue, front of the queue, and I'll check all its dependencies and reduce their out degree, because remove all the edges associated with it. So I will reduce the in degree of D minus minus, in degree becomes 0. Right, so if it is true, then we can complete all the courses. Otherwise, we cannot complete all the courses. Now we need to initialize. Now let's in degree number of courses we have assigned it with 0, dependency number of courses. Now we are creating a reverse graph, increasing the in degree, creating a queue count, and now we will go over all the courses, and then I push it into the queue and increase the count. We will pop from the queue as well here. Run it now. Yeah, that's it.